coagulation and flocculation, are important unit processes in water and wastewater treatment plants. The purpose of coagulation and flocculation is to remove suspended matter, turbidity, color, microorganisms, and odor-producing substances. Some common coagulants used are aluminium sulfate, alum, and ferric sulfate. Flocculation is usually defined as the aggregation of destabilized particles into larger flocks under slow mixing conditions. The flocks formed are subsequently removed by sedimentation and/or filtration. A useful laboratory experiment for the evaluation of coagulation and flocculation of an untreated water is the jar test. This test provides information on the effects of the concentrations of the coagulants, mixing of the raw water, and the water quality parameters such as pH and alkalinity on the coagulation process. The objectives of this experiment are to determine the optimum pH value and the optimum coagulant dose for turbidity removal from water. The experiment for determination of optimum pH for turbidity removal was carried out by pouring 600 milliliters of synthetic wastewater into 6 1-liter beakers. The pH of the wastewater samples in each beaker were adjusted according to Table 1 by using 1% of sulfuric acid or 1% of sodium hydroxide. Then, 30 milliliters of alum coagulant was added into each beaker. The initial pH and turbidity of the water samples in each beaker were measured using pH meter and turbidity meter, respectively. Then, the stirrers were turned on. The mixtures were to be rapidly stirred, at 120 revolutions per minute, for 3 minutes. After 3 minutes, the stirrer's speed was reduced to 60 revolutions per minute, for 15 minutes, at slow mixing. 15 minutes later, the stirrers were turned off, and the settling of flocks were allowed to occur for 45 minutes. After the flocks were settled down, the supernatant liquids were collected without disturbing the flocks, in order to measure the final residual turbidity and final pH. All results obtained were recorded. Next, the determination of optimum coagulant dose for turbidity removal was carried out by repeating step 1A. Based on the result of the previous experiment on determination of optimum pH, each beaker was adjusted to pH 7, using 1% of sulfuric acid, or 1% of sodium hydroxide. Then, the coagulant dose was added to each beaker, according to Table 2. After dosing each beaker, step 4A, until 8A, were repeated, accordingly. From the tabulated results, plot graphs of turbidity removal versus pH, and turbidity removal versus coagulant dose. And from the plotted graph, find the optimum value of pH and coagulant dose. Students are also required to discuss the finding, based on the results obtained.